Our next talk is Anton Slavers, which is, he is the head of engineering at Yandex Autonomous Driving Division, and he will talk us about AI and autonomous driving. So, Anton.
Thank you. Hi everyone, my name is Anton Slesarev. I'm head of engineering at Yandex Self-Driving Car project, and I graduated Moscow Institute of Physics and Technologies almost 10 years ago. Also, I'm an alumni of Yandex Data Analysis School, and today I'm responsible for algorithms which helps car drive themselves. And first of all, a few words about Yandex. Who in this room know about Yandex something? Okay, not so much. So Yandex is one of the largest IT company in Europe. We have many products. Our main product is a search engine. It's the most popular search engine in Russia with market share more than 55%. We also have geo services. We have e-hailing services, classifieds, e-commerce, and so on. Our taxi service, it's #1 taxi service in Russia. We work in 9 countries and about 300 cities. A lot of drives. To create great products, you need a lot of great technologies. We have our own deep learning libraries, natural language processing. We have our weather forecasting system, and so on. What is even more important for IT company, it's talented engineers, talented people. And that's why we work a lot with universities. We collaborate with, I think, most top universities, at least in Russia. We also have our own educational program, which is called School of Data Analysis. It combines academic research and industry and technology from Yandex. It's established in 2007. As I said before, I'm an alumni of Yandex School of Data Analysis. A lot of applications, a lot of more than 100 machine learning graduates per year. And 5 branches in Russia, Belarus, and Israel. And we are going to announce 1 year program here in Tel Aviv University. It will start in October. It's 8 months program with machine learning, a lot of programming. Languages will be English and Python, and you can find more details by this link. Anyway, you can find it by data, by Y data keyword. So let's switch to autonomous driving. We have a lot of technologies. We have a lot of brilliant people. We have e-hailing services such as taxi, and it's quite obvious for us to start self-driving. And it's our first video of our public ride on Moscow streets. It's not now. We don't have snow in Russia right now, but it was after the heavy snowstorm in February, and this right the next day. So a lot of pedestrians ride on the road. Edges of the road are not so clear, and I think conditions quite hard. And I personally proud of quality of this ride. Speed of this video 4 times increased, but you can see a real velocity of the car in the center. Yeah. So we need a lot of systems, which I'll tell you later, to provide such quality. We need to know environment, we need to detect other vehicles and pedestrians and know where we situated and so on. So let's switch to the brief overview of what do we need for self-driving. And there are few main components. First of all, we need to know where we situated. Then we need to detect other vehicles, pedestrians, buildings, and so on. And then we need to predict the future, where each vehicles are going to drive, if these pedestrians are going to cross the street or stay. Finally, planning subsystem decide where to drive and what exact smooth trajectory to drive through. And finally, control subsystem executes this trajectory with all physical limitation of real world and the car. And also, HD mapping are really important components of any of these subsystems. And again, the scheme of components. Today I'm going to focus on perception and localization. And now I'm going to provide 2 deep dives into specific components. Visual localization. As I said, we need to know where we situated. Usually we can use satellite navigation system, but it's not very robust solution and not very precise solution. How people localize themselves? They just remember the place and understand where they're situated. So something similar we can do with artificial intelligence. But the question how to represent an environment. We can explicitly represent by 3D maps. We can create landmark-based localization, or we can use implicit localization. So for explicit localization, we create such kind of dense 3D maps. When we have instant point cloud from a car, we try to correspond it with dense 3D map and finally realize where they're situated. Another approach to detect landmarks such as traffic lights, traffic poles, and so on, when we map them and correspond with detections and try to understand where they're situated. It is a more robust solution, but we need all that landmarks to be everywhere. And one more approach, we can put all images from whole our area into some index and work with it like normal search engine works with images. We can take an image from a car, make a request into image index and find our reference position. We use deep learning to represent images, and finally we need to refine the position. When we see 2 images, we can estimate transformation between 2 of them. And here's just a few examples how robust this search works. On the left, images during some evening ride, or on the right images from reference index, and it works quite well and robust. We even try to compare images from summer and from winter and deploring make magic. So it's really a robust technology. And another what we need to provide fast search. My colleague Artem Babenko created the multi-index structure. It's one of the approximate nearest neighbors technologies. Basic idea how to split space and choose the best cell where to find nearest neighbors. Details you can find by the link, but by this technology we can find in billions of images in image search at Yandex, for example. So we can collect huge indexes, a lot of images. And finally, we need to refine the position. We need to refine a position. We see two images and we calculate some transformation between them. We can do it by neural network. So we have a lot of advantages of implicit localization, such as simplicity, scalability. We don't need to use slider, and right now we have about 1 meter accuracy right now, and I hope in future it will be even better. So as I understand, we have lack of time, but I have half of my presentation. What should I do? It's not okay, but let's do it. So conclusion, we have a self-driving project at Yandex. We don't have time to provide a lot of details. If you want details, tomorrow we will make a meetup at self-driving 101 meetup. Maybe we have a room for there. But for now, I should finish. Thank you for your attention. You can catch me later.